Welcome to another event in the Channel Islands Maritime Museum Speaker Series. Our featured speaker today is Ryan Kittell. He has a master's degree from UCLA in Atmospheric and Oceanic Sciences and is currently a forecaster and marine program manager for the National Weather Service. Today, he will give us an overview of marine services provided by the National Weather Service, including a look at the local weather phenomena and how to receive National Weather Service products. Ryan, you have the floor.
Thank you, sir. Good day, everyone. As you mentioned, my name is Ryan Kittell. I am a forecaster at the National Weather Service. I'm from Southern California. I grew up in Redondo Beach, California, which is near LAX airport, if you don't know where that is. And I grew up on the water a lot. My dad had a boat most of my life, even a side commercial fishing business. I actually went sword fishing. We used to have sword fishing out here. And so I grew up on the boat. My first few jobs were on the water as a attendant at the fuel dock at the King Harbor Marina in Redondo Beach, and also as a deckhand on Catalina Express, the ferry that takes folks over to Catalina Island down south. So love the water. When I graduated from UCLA, I got a job with the National Weather Service. I've been there for about 15 years now, and I gravitated quickly to the marine side of the house, and we do a lot of forecasts and services for the marine community because weather impacts them a lot. And that's the main point for my talk today, talk a little bit about who we are, and then explain a little bit of the local phenomenon that we have in Southern California that's particular to boating interests and marine interests. And then how to get our information, primarily on the website. And so hopefully some of this information will be useful if you're a mariner, but even just for the general public if you want to know how the weather impacts the local area and how to find out more information about it. So without further ado, again, what to expect. This is a picture of our office. We have a nice little bunker office in Oxnard close to the Camarillo Airport. And we've been there going on, I think it's close to 30 years. And you can see my boss's car over there, and my car is somewhere in there in the parking lot. So we also, when there isn't a pandemic, we do offer tours for folks. A lot of school-age children come through, so they're interested in the weather. But we are there in Oxnard, so we're locally centered. And these are the things I'm going to talk about us, about our marine services, the local phenomenon, how to get our information. So, big picture, National Weather Service. We actually are part of the federal government. We fall under the Department of Commerce. And under the Department of Commerce is NOAA. A lot of folks are familiar with NOAA, NOAA. It's a big scientific agency within the federal government. And we're just one branch of NOAA, the weather side. There are lots of other branches of NOAA that deal with fisheries, deal with marine biology, deal with a lot of research. But we're just the operational weather forecasting arm of NOAA. The map behind me shows those yellow squares. It might be hard to see, but those are all different weather forecast offices. Local weather forecast officers. There's over 120 throughout the country, and they cover the local area. We also have a few outside of this map in Alaska and Hawaii, and even out in Guam and America Samoa and Puerto Rico. There are also some national centers. Most of them are back east that handle kind of the big picture things or some of the things that are outside the immediate coastal areas, like the Ocean Prediction Center, and then the National Data Buoy Center maintains all the buoys in our area for the whole country. We are open 24/7, which a lot of people don't know. So there's at least 2 people on shift 24/7 at all these offices, including ours. And so even in Southern California, when a lot of people think the weather's nice, the weather never sleeps. And oftentimes there's a lot of interesting weather going on at night. And if for nothing else, a lot of work goes in overnight to prepare the forecast for those who wake up early in the morning and want to know what to expect today. And so that's another reason why we're open 24/7. So our office, there's that bunker picture again. Inside the office, we have a lot of computer screens. This is one of our workstations. And you can see we have a lot of screens because there's a lot of data that we'll look at. We look at buoy data, satellite data, radar data, computer model data, weather stations, you name it, webcams. We have all sorts of information, and that goes into the forecast process to try to come up what's going to happen in the future. There's a map that kind of shows generally where we are. If you aren't familiar with this general area, we're between LA and Santa Barbara in Ventura County. And we're just on the Oxnard border between Camarillo and Oxnard, again, near Camarillo Airport. off of, what are we off of? Del Norte and Rice, if you know that area. All right, so the area that we cover, as it goes there, we cover basically the land areas from Los Angeles to San Luis Obispo counties. So that covers Los Angeles, Ventura, Santa Barbara, and San Luis Obispo counties. We also cover the marine areas, the ocean, out to 60 miles. And you can see the map out there. It includes the Channel Islands, includes San Nicolas and Catalina Island as well. We divide the area into something we call forecast zones, and you can see that with the 6 numbers out there. Each of those areas, we produce a standard 5-day forecast for each of those zones. The zones were drawn up many decades ago. I don't know who the author of these lines are, but we've been doing it for a long time. And they were drawn up with a lot of different factors, whether the consideration that the weather is fairly similar in each of those areas, or they're demarcated by well-known geographic landmarks. And so that's how we got the divisions that we have here. It is a balancing act. A lot of folks ask, well, why don't you break it up into smaller zones? There are ways to get even more detailed information, and I'll show that to you later. But it is a balancing act between having too big of a zone, too few zones with big areas where the finer details get washed out, and then between that and having too many little zones where if you're a boater and you're going from here to Catalina and you have to look at 5 different forecasts, that's not very useful. So it's kind of a balancing act, and we've been doing this 5 or 6 zone structure for a number of years now, and it's been working out pretty good. So the National Weather Service itself, I mentioned we are part of the federal government. We do have a mission. Like most government agencies, we like mission statements. And there's the long version, but I highlighted the 2 main important points of why we exist. Number 1, we exist for the protection of life and property. So if people know when impending and serious damaging weather is coming, they can make preventative actions to protect life and property. But also for the enhancement of the national economy. And that's how we fall into the Department of Commerce. And that one's a little bit less obvious, but I think you can kind of guesstimate as far as how good weather information can help with the national economy. My favorite example is a few years ago, Krispy Kreme Donuts emailed us and asked how they can get a feed for our temperature forecast. And they found a direct correlation between the weather, how hot it gets, and how many donuts they sell. When it's really hot, less people buy donuts. When it's really cold, more people buy donuts. So if they know the forecast ahead of time, they know how many donuts to make, and there's less waste, better profits, enhancement of the national economy. So that's kind of a funny example, but you can think of other examples where businesses, lots of businesses are very sensitive to the weather, and if they know ahead of time what to expect, they can make good business decisions. And so that's where our twofold protection of life and property, number 1, but 2, also protection or enhancement of the national economy. And the way we do that is by 1, just producing good forecasts so people know what to expect. And then we also produce things called watches, warnings, and advisories, where we really want to heighten people's awareness of serious weather. So we could just do general, like what's the high temperature going to be, what's the wind going to be. But sometimes it gets really hot. Sometimes it gets really windy. And we issue these warnings, advisories, and watches to highlight those situations. This isn't a run-of-the-mill kind of day. We want to highlight that. And that's through our watch and warning program. The other aspect, which is growing in our agency, is something called impact-based decision support services, which is this buzzword. And really all that means is that we are now starting to build relationships with high-level decision makers so that we can be their liaison, their communicator for understanding what's going to happen in the future weather-wise. Before, we would just like crunch the numbers and send it out to the world and just, okay, whoever needs it, go grab it. But now we're starting to meet with fire chiefs, like with the FAA, with the Coast Guard, with harbor patrols, developing these relationships, going out to lunch with them so that when there is a big deal storm coming, we could say, hey, this is a big deal. You need to start doing some preventative actions. And now there's a face behind it, and there's a little bit more trust behind it instead of just looking at a computer screen. And if something doesn't make sense, now they can ask us questions, and we could try to explain it better to them. And that just, if you think about our mission statement, that just does it a lot better than just throwing it out and say, hey, go grab it. Obviously, we can't have relationships with every single person, but we do try to find those high-level people who make decisions that impact lots of people. And so that's one of the big pushes in our agency. And then we also we communicate in all sorts of ways, and I'll show you the different ways. Through web, we have a radio station, we have phone services, all sorts of ways, and I'll show that to you later. All right, So let's just start with some of the vanilla stuff, our routine forecast. If you're a boater, our flagship product is the Coastal Waters Forecast. The black and white text, which you probably can't read, is on the left. But if you're a boater, you're probably familiar with this. It's a 5-day forecast that tells you the different wind speeds, the wave heights, and periods and directions, and what other kind of weather you might expect. In each of those 6 zones, if you remember that map, we produce these 5-day forecasts for each of those 6 zones. They go out to the web. They also play on the marine radio. So if you have marine communication radio, there's usually a little weather button on it. And when I grew up as a kid, I would listen to it, and I had no idea where it came from. I just thought someone did it, and we get it. And now I know where it came from. And so there's men and women in Oxnard that are producing those forecasts. And if you're on a boat, sometimes far out from self-service, you can still get that weather radio station, and that's why we still produce that. And it's a very valuable service that we provide. From what I hear from boaters. So that's the Coastal Waters Forecast. We also have digital forecasts where, with advancing technologies, now we can actually put forecast information on maps, so that you can now see, instead of looking at reading a narrative, you can actually see on a map where we think the winds are going to be stronger, where the waves are going to be higher. And that's all available from our website, which I'll show you in a little bit. And we produce those forecasts 7 days a week. It goes out 5 or 7 days, and we're updating it constantly. But the main forecast push, or the issuances, are at 3 p.m. and 3 a.m. Each day. But we'll update as needed. I talked about the Watch Warning Advisory Program. So this is when we want to highlight very serious type of weather that's not routine, and we do that through this program. And so these are the general things that we'll issue for the marine community. Small craft advisories, which are fairly common. That's whenever the winds are above 21 knots, if the waves are really steep, lots of whitecaps out there, or if there's just really large waves independent of the period and steepness, we'll issue a small craft advisory. And that's supposed to let folks know, hey, if you have a small boat, maybe it's not a good day to go out. Most people ask me, well, what's a small craft? And if you have a boat and you don't know if your boat's a small craft, just consider it a small craft. And that's usually the best rule of thumb. And the other nice thing, there are responses that come up from this. So if we issue a small craft advisory, most of the harbors here will allow free anchorage inside the harbor. So they'll raise the red flag near the harbor patrol. I think they do it here in this harbor, also in Ventura. You'll see like a red flag. That's what those flags are up on the screen. And that also communicates that there's small craft advisory out. And if you are a traveling boater, you can seek free safe harbor in most of the harbors out here for safety purposes. So there are some kind of consequences of these things that we do. Gale warning is the next step up. That's whenever the winds are just really strong. This is usually the strongest type warning that we have in this area, 34 to 47 knots. That's going to be generating very strong winds and very steep, dangerous seas. Pretty much any boat out here shouldn't go out. And even island packers, Catalina Express, the main ferries out here, this is usually a trigger point for them to consider canceling trips whenever we issue a gale warning. Storm warning would be the next step up. We have never issued one for this area up on the Central Coast. We've issued a couple in the last decade or two. It's very rare, but sometimes we do get winds close to 50 knots, and you can imagine how dangerous that could be. And then the mythical hurricane force warning that we could get, but we haven't, at least in the latest future that we've had. Special marine warning is the analogy to the severe thunderstorm warning over land, but for the water. So whenever we see a very strong thunderstorm capable of reducing strong winds, hail, even a water spout, which is a tornado over the ocean, we'll issue one of those. If you're listening to the radio station on your marine radio, it'll stop the broadcast and just go right to the broadcast of that warning, so that you know where. We'll describe where it is and what area to avoid. Then the marine weather statement is kind of the catch-all for everything else. All right? If there's something we want to raise awareness to the marine community, that there's something significant going on, we'll issue a marine weather statement. And these are some examples of what we'll issue them for. A general threat of thunderstorms, a strong storm way out there in the future that we're fairly confident on. It could be even non-weather, like a hazardous oil spill. We may issue a marine weather statement for that. We also do it for dense fog. I think we had one out here this morning. There's a lot of dense fog out there. Just to highlight, it's in our forecast, but we want to raise awareness that, hey, very poor visibilities, probably best just to stay in harbor today. My dad has a 14-foot Boston whaler, and he's going out all the time, and That's the one I'm always worried about. He goes out, he's in Redondo still, he'll go out into the shipping lanes in San Pedro Channel, and it's like, I don't want him going out when there's fog, and so I kind of had my dad in mind whenever we try to emphasize the fog forecast. And I tell all the rest of my staff, hey, think about my dad. Make sure we're doing good on that. Obviously, I care about everyone else, but I'm thinking about my dad, too. We'll also issue for tsunami information, because most of our tsunamis that we get here don't cause the death and destruction that you see elsewhere in the world, but it does cause a lot of damage to the harbors. And so that's why we want to raise awareness for those as well, for the marine community. All right, moving on. I did want to mention a little bit about waves themselves. So most people are glued in when they hear about the wave heights or the wave system. They're keyed in on the heights, right? Bigger waves mean more dangerous. But it's most important, just as important, is the wave period. And the wave period is how frequent are those waves. Usually we denote them by seconds. So if we say there's a 4-foot wave at 10 seconds, that means you're going to get a wave like that, a wave every 10 seconds. So the wave comes, and then 10 seconds later another wave will come, and then so on and so forth. And if the period is shorter, say 5 or 6 seconds, that means the waves are more frequent. They're coming wave, and then another wave, and then another wave, right? Versus a long period, 15 or 20 seconds, wave comes, you're kind of waiting a long time, then another wave comes. So when the period is shorter, that's much more hazardous to a boater because the waves are more frequent, they're steeper, and those are the ones that you can't just kind of roll over. You're just getting constantly bombarded if you're a boat. And so this is a great example, an animation if you can zoom in on that to show on the left-hand side, that's an example of a 4-foot wave at 16 seconds. And this is a theoretical wave. You wouldn't really see waves like this out in nature, especially the one on the right. That looks like a boat wake, but this is just kind of to denote and show what visibly these things are showing when we say height and period. So 14 feet at 16 seconds versus a 13. I'm pointing over there, but I have a laser pointing. So 4 feet at 16 seconds, and then 3 feet at 6 seconds. So this wave is smaller, but has a shorter period. And you can imagine if you're a boat, which wave would you want to be on? Probably the bigger wave, right? It looks almost glassy and flat because it takes so long, they're so fat, these waves, that you could just roll right over them even though they're larger. The waves that are shorter period, even if they're smaller, could definitely cause more, if nothing else, a less pleasant ride out there, but definitely if they get larger at short period can cause some significant hazards to a boater. So period is just as important as height. It's really looking at both of them together to get a good sense of what's going on the ocean. All right. I'm going to skip this one. So a little bit about the tsunami program itself. We do issue tsunami warnings, advisories, and watches. And we do that through our National Tsunami Warning Center. They're part of the National Weather Service. They're up in Alaska. And they have responsibility for most of the United States, including our area. And so they have someone there 24/7 monitoring the earthquakes. And whenever there's a large earthquake, they quickly run a computer projection to assess whether or not there's an imminent tsunami threat. And so when they issue something, the local weather office here has a responsibility to relay that information to the media and to the general public and maybe add some more detailed information as far as like maybe certain harbors that might be more impacted than others. And so that's what we do. We're kind of their liaison to the local community, and we'll add some more information based on what we've learned in the past. And these are just the general tiers. A warning means that there's danger. A 1 meter or higher, basically 3 feet or higher wave is imminent. And it's important to remember a tsunami is not like if you remember the classic Japanese painting of this large cresting, breaking wave. That's not a typical tsunami. A tsunami is, think of more of a high tide, low tide surge. It's a tidal surge versus a big wave. And so in this harbor, you might see a 7 foot, at the most, a 7 foot variation between high and low tide. But that occurs in a matter of 6 to 12 hours. When you have a tsunami, you can have similar ranges like that, but it happens in 20 to 30 minutes. So you can imagine the types of currents, the types of, maybe the docks breaking off, or sometimes can even go over the pylons, the types of damage you can get in a harbor with that type of surge activity. That's usually the big danger for us for tsunamis. All right. Next, let's talk a little bit about our local phenomenon. So we could start off with the boring, what normally happens in our area. And this is the prevailing wind direction. So what's usually and what's typical Obviously, we have lots of different types of winds, and we'll talk a little bit about those. But generally, the most common type of wind condition is something like this. If you look at this map here, I've got our area, basically the Central Coast, San Luis Obispo and northern Santa Barbara counties, and then Southern California down here. This is typical wind in the afternoon. You have this strong, it might be hard to see these arrows, but this northwesterly wind blowing from the northwest to the southeast. The colors denote wind strength, so it's like a 20, 25 knot type wind. And then down here in the channel, in the eastern, especially the eastern side of the Santa Barbara Channel, and then off of Los Angeles County, much weaker winds and more of a westerly onshore wind. And this is the typical kind of general pattern that we get. And the reason of this is, if you look at, because of lots of different factors, the temperature difference between the poles and the equator, the fact that the Earth is spinning, we have these prevalent highs and low pressure areas. And for our area, the most common feature we have is this thing called the Eastern Pacific High. And that's off of the west coast of the United States, basically 9 to 10 months out of the year. And air likes to blow clockwise around a high. And so as a result, on the Central Coast, they're in this region of that Eastern Pacific High of that north to northwesterly type wind. The wind can't make the turn around Point Conception and kind of spin off the coast more here. And then in this area, the winds are generally calmer because of the Point Conception, an abrupt change in the topography and landscape here. And now you're just more in a sea breeze regime. And the sea breeze, the mechanisms of the sea breeze circulation is this. You basically have warm air, especially in the daytime, warm air over the land, and relatively cool air over the ocean. If you grew up in this area or you live in this area, you know the beaches are usually cooler than the valleys. The ocean is a great moderating source. It has to do with heat capacity, where it takes a lot more energy, a lot more sun energy to heat up water versus land. And so as a result, the water doesn't warm up as much during the daytime, but also doesn't cool off as much in the nighttime. So typically, if you live along the coast, you have a very, very small temperature range between the morning and the afternoon. Whereas if you live in the valley, say in Ojai or in Van Nuys, you get a large temperature range. In the daytime, when the valleys are super hot, all that air is rising up, and it induces this area of low pressure. But you can just think of this, if you can kind of think back and use your high school physics. Maybe most people did take physics in high school, I don't know. But science class, where if air is rising, that air is just getting sucked up. It's pulling air from below. In order for air to go up, it's got to pull air from below. And if you think about this area here, air is rising. It's pulling air from the ocean inland. And then over here, the air is cooler, and cold air likes to sink. And you can kind of imagine this nice circulation where the air is constantly being refed, but this cooler sea breeze air is keeping the coastal areas cool. And then eventually it'll cool down the valleys later in the day. But you get this warm air rising, sucking in the air from the ocean, and then cold air sinking, and you get this nice circulation. And that's the sea breeze circulation that we have over Southern California, pretty much most of the coastal areas in the country and around the world. And for LA area, most of the time that means that sea breeze is mostly a westerly direction, coming from the ocean, which is to the west, and blowing to the east. Over Santa Barbara County on the south coast, it's different, because now the ocean is to the south and the hot air is to the north, and they get more of a southerly, southwesterly type sea breeze. And it's all just based on the orientation of the topography of the land. So over Malibu, their sea breeze is mostly southerly or southwesterly. In Oxnard, it's westerly. And you could just kind of make this, if you could imagine this scenario happening all along the coast, it makes sense why you get a westerly wind here and more of a southerly wind here. Does that kind of make sense? It's kind of cool. Just way over your head, don't worry about it. I don't know when you're watching this. If it's like 8 o'clock at night, this is probably way too much, but we'll move on. All right, let's see. We also get northerly wind events. These tend to be pretty strong, and typically they happen in the late fall and winter months. If you live in the Santa Barbara area, you've heard of that term sundowner. They're usually conducive to high fire threat. We've had lots of large fires during sundowners. And you can notice just by the colors they look warmer, because a lot of times they're stronger. We get really strong northerly wind events. And you can see the areas that are impacted. remember over here where most of the Santa Barbara Channel, during the normal circulation, the sea breeze, pretty light winds. During a northerly wind, the Santa Barbara Channel can be very strong. And the winds around the Channel Islands can be very strong. And so usually if you're a boater and you want to go to the Channel Islands and we're expecting a strong northerly event, it's a good idea not to go. It's hard to find areas that are safe. And so that's a northerly wind. Even down in LA County, we can get winds going through the I-5 corridor, even down into LAX, and you get a good 20, 30 knot wind right off the coast, whereas normally it might be a kind of a weak 10 knot wind in the afternoon. This northerly wind can be a lot stronger, and it usually happens at night. So the timing is a lot different for these northerly winds. Typically our stronger winds are in the afternoon when that temperature difference is the strongest. These northerly winds usually peak overnight. All right, and then the next one is the northeast wind. And if you've heard of that phrase Santa Ana, this is usually what we mean, a northeasterly wind. We denote the winds by where they're coming from. So a northeast wind means air is coming from the northeast, pushing towards the southwest. So that northeast wind. And this, you can see the areas that are usually impacted more. Santa Barbara Channel now, the western side is usually pretty calm. Whenever we have a Santa Ana wind event, the western part of the Santa Barbara Channel is usually pretty nice. Whereas the eastern part, here in Channel Islands Harbor, Ventura Harbor, out to Anacapa, Santa Cruz Island, it can be really windy and quite hazardous. 20, 30 knots that can generate pretty steep seas. Not a good day to go out. Those winds go all the way through Malibu, and then there's this lull, this kind of shadow area over most of metro LA. And that's because we have these huge 10,000-foot mountain range, the San Gabriel Mountains, that block most of the wind and keep it up in the air as opposed to coming down to the surface. I grew up right here, and usually my idea of Santa Ana's is nice, warm, beautiful weather. Let's go to the beach. There's no wind. Now I live in Newbury Park, and when I hear Santa Ana, it's like, oh, it's going to be windy and dusty. So totally different, totally different. And you can see in this map that area that is least impacted and why, because of these huge mountains upstream. But over here, those mountains kind of end, and Orange County definitely gets impacted more. And on a stronger event, especially a colder event, it can get all the way out to Avalon and Catalina Island. And there's a long history of very dangerous northeast wind events that have hit Catalina Island. Most recently in 2014, around New Year's, which I didn't realize this until recently, but it's actually very busy in Avalon on New Year's Day. It's cold, but they have a big party, a big festival. So usually there's lots of boats in the harbor. And when they had a very strong event move through there, I believe the winds exceeded 40 knots, and 2 people died from that event. One of them was a harbor patrolman trying to secure some boats. So it's very dangerous. It can be a very dangerous situation. It doesn't happen every day, but it does happen. And that's one of the reasons why we're around. We can let the harbor patrol know, hey, expect a big Santa Ana wind event in 2 days, and they can make some precautions to try to mitigate the damage and also the threat to the public. All right, what do we have next here? Here's another picture of Santa Ana. So here's actually Avalon Harbor during a strong Santa Ana wind event. The waves can get really strong. That harbor is totally open to the northeast and the east, and so you get really strong waves. Similar conditions happen out in the Channel Islands as well with these type of easterly winds. And you get large waves. This is a large wave breaking over the little seawall there. And this is actually a observation from satellite. There's this really cool satellite instrument that can measure the ripples on the sea surface to determine the wind speed, which is really amazing. And this certain specific image actually caught a strong Santa Ana wind event. And it's hard to see the arrows. They're all pointing basically from right to left, but the areas of red are where the winds are really strongest, and you can see where we have data, the northeast winds even going way out beyond the Channel Islands, hitting Catalina, and even down here into San Diego and even into Mexico. They can get really strong winds from these northeast wind events. All right, and then real quickly, we have another phenomenon called the Catalina Eddy, if you've ever heard of that. Usually the winds don't get too strong, but what's of note about this phenomenon is that usually these winds peak in the morning time. And if you're a boater, that's usually the time you're out, especially if you're making trips to any of the islands off the coast, because that's usually when the conditions are the nicest. The winds are the calmest, the waves are the smallest. But if we have a strong Catalina Eddy, you can actually get fairly significant, even up to 20, 25 knot winds from the southeast. Those northwest winds that we showed off the Central Coast, when they get really strong, it causes this circulation, this kind of gyre. And sometimes you've seen things like that on streams. If you ever see like on a creek and the river is flowing this way, and then there's this kind of like cove, and you can kind of see things swirling around. Something similar happens with the winds here. And sometimes this circulation can get really strong. And the reason why it's significant is that here in the San Pedro Channel, this is where lots of people are going to Catalina Island, and you can get fairly strong winds here. And sometimes that eddy will extend into the Anacapa Passage and even into some of these passages between the islands. So people go out to the islands, expect good weather in the morning, and this can kind of wake them up to the weather not being as nice. All right. The other aspect and the last thing to talk about for wind is if you think about all those different wind events and wind directions and wind regimes that I discussed, they actually get enhanced because of the topography and our land orientation here by something called the Bernoulli effect. It's that same effect that I know it's probably illegal nowadays to use a hose without a hose nozzle for water restrictions, but I remember when I was a kid, you take the hose nozzle off, you turn on the water would flow, and then you put your thumb over half the hose, and then the flow would get faster, right? You guys all kind of remember that happening. That's the Bernoulli effect. You were doing the Bernoulli effect even back in the day with a hose. And basically the reason why is that there's a fluid flowing, and if the area that fluid can flow out of gets restricted, and you want that same amount of fluid to go through, it's got to speed up, right? Otherwise, there'll be a blockage. And that happens in nature, too, with wind. And so whenever you get wind blowing, say we had a Catalina eddy circulating this way, and all this southeasterly wind is going this way, and then it encounters this San Pedro Channel, this restriction between Catalina Island and the mainland, well, that wind is going to speed up. And that's where you get this enhancement. Same thing happens in the Anacapa Passage. And in between all these islands, you can imagine with the right wind direction, the winds can get enhanced and be even stronger. So if you're on a boat and say you're going from Santa Barbara Harbor out to say, Anacapa, it might be nice here, but as soon as you get close to this passage, the air is getting restricted and enhanced and get a lot windier. So that's another thing to be of note if you're a boater out there, that you could and should expect winds to be enhanced between these islands and in these passages. We also get things like that happening in the passes and canyons on some of these areas from land winds. So if you think about a Santa Ana blowing through Malibu, if you've ever driven through Malibu, there's all these canyons. You can imagine the winds getting funneled and enhanced there, and they can make it all the way out to the ocean as well. So the winds, I used to live in Santa Monica and commuted to Oxnard. I had the horrible commute of driving up PCH every day, which was beautiful except when it rained and everything shut down. But I know whenever we'd have Santa Anas, it's just a white choppy mess right off the coast. From a Santa Ana, which most people might think of good weather, especially if you're coming from LA. So that's the Bernoulli effect. All right, so that's pretty much for local communication or local weather phenomenon, but let's just talk about how to get our information. How do we communicate information? We have our website, which I'll talk a little bit about here in a second. We are also responsible for those wireless emergency alerts, colloquially called WEA alerts, whenever you get this loud screaming text message on your phone, whenever there's an Amber Alert. But we also have the power to do that for weather. If there's a tornado warning, a severe thunderstorm warning, a flash flood warning, your phones will get automatically beeped and buzzed unless you opt out of that. When this system first came online, it would buzz every phone in the county that we would issue a warning in. So let's say we issue a little flash flood warning for like a little canyon up in the mountains in LA. All 14 million people would have their phones buzzed. That was a poor decision. Now they've enhanced the technology so that basically if your phone is connected to a cell tower that's impacted in the area that we deem hazardous, then you'll get alerted. Otherwise, you won't get alerted. So if there's a flash flood warning in Palmdale and you live in LA County, only if you're in that general area, that specific local area, you'll get buzzed. Otherwise, you won't. That was a great improvement. And I think it's a very powerful resource because most people have a phone. We also do TV alerts. We also will buzz your phones with those sounds that I remember when I was a kid and I'd be homesick watching I Love Lucy, and they do the weekly test of the emergency broadcast system. Now it's the emergency alert system. And we will do that too. Again, ways of getting the word out to folks. Especially 10, 20 years ago, a lot of people were watching TV all the time. And if we can alert them through the TV, that was pretty powerful. And I think now that the phone has kind of replaced that. But we still use this because it does reach some folks. We do social media. We're active on Twitter and Facebook. We even have a phone still with live people that you can talk to. Our weather radio that I talked a little bit about that boaters have built into their marine radios, marine communications radio. And then we have good relationships with newscasters. So Johnny Mountain, I don't know, he's retired now. Dallas Raines, all those weather people, the personalities that you see on TV. We have good communication with them, and they get a lot from us by giving them good answers and good explanations of things. But they're also good spokespersons for our messages. So if we want to alert folks, they do a good job of doing that. And so they're a really key resource for us. And I think it's a good symbiotic relationship. All right, so let's finish by talking about web tools. Most people are on the internet. How do you get our information? We are accessible through weather.gov, so not weather.com, which is what my wife uses, but weather.gov. That takes you to the National Weather Service. It is a government website, so expect a lot of poor organization and lack of eye candy, but there's a lot of good information. If you go from weather.gov, put a little / and type in LOX or Los Angeles, that'll take you to our local webpage. Or you can go to weather.gov, click on the map in Southern California, it'll take you there. And this is our general homepage. And what I wanted to focus on is two areas to quickly get a forecast that you might be looking for. First is up here is a city, state, or zip code search box. So if you type in your zip code or your city and state, hit go, and you'll get a specific forecast for your local area, which is awesome, without ads and banners. And it's also written by people who live in the area versus a lot of the private places that live back east or something like that. They're all great, whatever service you find good, but I like to plug reasons why we're good too. And so that's one way to get it. We also have a map here, and it'll light up with different colors if we have different warnings or watches or advisories. This is kind of a boring day, but you can see up here there's a purplish, pinkish color, and that corresponds with a small craft advisory. And so if there's any kind of serious weather right away, just looking at this map, you can get a good 20,000-foot view level on if it's a dangerous weather day or not. If it's a nice white map, it's probably a pretty benign weather day. If there's lots of different colors going on, there's something interesting and potentially dangerous going on weather-wise. But what a lot of people don't know is you can actually click on this map. Say you're a boater and you want to know what the forecast is. You can also click on this map again, and you can get a point forecast. So say you don't want a forecast just for the whole zone. It's good to start that way. But say you're going fishing in a specific spot, or you're going to an island. You can actually click on this map again, and it'll take you to a point forecast. A forecast for about a square mile area. And it'll even give you a nice little icon section up at the top, and a 5-day forecast for that specific location, which is kind of nice. And you can even click on this map again and just point around and see how the forecast changes for different areas. So it's a pretty powerful tool. Really important to check the big picture, the zone first, and then drill down. We have over 12,000 of these points to keep track of, so I can't bet my life on the accuracy of every one of those little points. But the zones, we do spend a lot of time making sure those are good. But this is a really good resource if you want to drill down a little bit. Another way to get our information if you're a boater is through the marine weather section page. So here's our home page again. Below that, you'll see these icons of more specialized weather, and there's a marine button you can click on. And I have a page here with all sorts of good information. You can get observations. You can get the weather radio information. You get tides, charts. You can even get the slides to this presentation. And this map here, you can actually mouse over if you're on a computer, and it'll give you the current conditions for each of those buoys, which is kind of nice. And I'll talk a little bit about buoys at the end here. Almost done. Also from that page, you can get our forecast discussion. And this is kind of, the forecast discussion is an opportunity for the forecasters to give extra information that's not in the forecast. Let's say that we have to make a decision on if it's going to be 80 degrees or 70 degrees, and we think there's a possibility of either of those. This gives us an opportunity to say, okay, we went with 80, but here's why it could be colder than that. Or we think a storm's going to pass us to the east, but there's a chance it might actually hit us, and here's some reasons why. So this gives you a little insight into the forecast process. Kind of think of it as a weather blog from the forecaster in charge. And we actually have different sections. We have a general public section, but we also have a specific section for mariners and for pilots. And so if you want to find out more information about what went into the forecast as a mariner, you can hear directly from the person that wrote that forecast, which is kind of cool. So that's the forecast discussion available from our website. If I go back one page, there'll be a link in here, but there's also a link down here that says forecast discussion from our homepage. A couple other pages to finish up with. Observations, if you click from that marine page to observations, again, you can click on this map, mouse over this map, and quickly access the current conditions in all these buoys, which I'll show you in a map at the very end. And then all sorts of different information for different weather observations. We have a lot of weather data available here. We're actually very blessed to have it. We have pushing 17 weather buoys in our area. There's some areas, some offices only have one. We could certainly use more, but we have a lot, and that all is freely available on the internet. So that's our observation page. We also have, talking about the buoys. Here is a map, if you can see, of the different buoys in our area. The white buoys are NOAA buoys that are part of our agency. The purple ones are part of the CDIP program, which is maintained by Scripps Institute of Oceanography in San Diego. Air temperature. The Scripps buoys are called wave rider buoys. They look more like just a bobber, and they bob up and down. They're very sophisticated instruments, but they don't measure wind speed, but they do measure wave height and period and water temperature. And so these type of buoys are out here in purple. Some of these have actually been decommissioned. Since I've updated this map, I need to update this map. But the white buoys are still there. And so you can see we have a lot of data in our area. We actually have a lot of good information that's out there. And then lastly, we do have a mobile page. So we don't have an app. A lot of folks ask, hey, do you have an app? Or, hey, I have your app. It's great. And we're like, we don't have an app. Since we are a federal agency, we're part of the public domain, any private developer can use our logo and use our data and repackage it and sell it to the public. And that's great. They provide a service. So you might see a NOAA app on the App Store if you have a smartphone. That's probably showing our data, but we're not responsible for the development and maintenance of that app. But we do have a mobile web page, and basically just putting the word mobile at the end of our link. And I'm also the webmaster. I've designed some of these pages, and they work really well on your phone, and it functions basically like an app. And you can even put a little icon on your phone, which I have instructions for on our website, to make it look like an app. So you have like a nice little NOAA logo you can click on, and it'll load it up, which is nice. And what about other sites? There are lots of other weather sites out there. They're great. If you love them and they prove useful to you, use it. Go for it. I don't slam any other resource that's out there. But I ask you to try us out, and hopefully you'll find that we're useful as well. And since we are taxpayer funded, it costs every taxpayer about $5 a year to fund the whole National Weather Service, which I think is a good deal. Maybe a little bit. Right? A cup of coffee or the whole National Weather Service. So thank you very much. Actually, all of NOAA. So thank you very much for that, for your $5 contribution for my job, and my kids, thank you as well. And so that's pretty much it that I have for my presentation. Thank you very much. Here's some contact information if you want to reach out to us. We have a contact at our website. We also have a phone number that you can call and talk to folks. So check us out, and thank you for watching. All right.
Do you have a connection with the planning for El Nino on a given basis?
It's called the Climate Prediction Center, and they're in charge of long-range forecasts. So our local office really just looks out 7 days. Maybe we'll look out 14 days. That center looks out weeks and months in advance, and El Nino is part of that. So they do all the official forecasts for El Nino, and then we will look at their stuff and kind of understand it and how it might apply to our local area. And a lot of times we'll try to communicate that and explain that to the local partners here who may not understand what the implications of that. But basically El Nino for our area, unless it's a very strong El Nino, the history has shown it's still a flip of the coin. Most people are like, oh, it's an El Nino, we're going to get a lot of rain. Unless it's a really strong one, if it's a weak or moderate, it's still equal chance of anything happening. So, good.
Thank you very much, Ryan.